And we're back, everybody. Thanks for tuning in again to Mr. Laver's YouTube channel. Oh, I hope you can hear me. Now, there we go. There we go. Turn the computer around. Don't forget to subscribe. Up to 55. When we get to 100, we can do a giveaway. Maybe some Ticonderoga pencils. Yeah. There you go. All right. Let's take a look at this problem. The design of a box specifies that its length is 4 inches greater than its width, the height is 1 inch less than the width, and the volume of the box has to be 12 cubic inches. What is the width? Again, the design of the box specifies that the length is 4 inches greater than its width, the height is 1 inch less than the width, and the volume has to be 12 cubic inches. What is the width of the box? All right, so let's analyze what's going on here. I have the volume, right? I know the volume. What's the formula for volume? Length times height, right? So volume is equal to length times width times height. All right, so now what does that mean? Well, I know, let's think about our knowns and our unknowns. Our volume is known, it's 12. Our length, width, and height. We're looking for the width, right? Oh, no, I'm sorry. Yes. We're looking for the width, so let's call that x. If the width is x, what is the length? X plus 4, right? The length is 4 inches greater than its width. And then what is the height? X minus 1. Can I solve for x here? Yes. Take a look. This means that I've got 12 is equal to my length, x plus 4, times my width, times my height. That's an equation that I can solve. Let's do it. Let's multiply. That means we get, let's just multiply those two together real quick. 12 is equal to x squared plus 4x times x minus 1. That's a minus 1, really? Minus 1. And then let's FOIL that. First, we got an x, well, x to the third outer minus x squared inner plus 4x squared last minus 4x. Does that follow me there? So that means we get 0, and I'm going to bring over the 12 now. I'm going to do 2 steps at once. Bring over the 12 to the right side. X to the third plus 3x squared minus 4x minus 12. And now I have to solve for x. I have to get x completely alone. Right? I have to solve for x. Now, how do I do that? Well, my first instinct is to try to factor, right? Let's factor. Let's see if I can. There's no GCF, so let's try to factor by grouping. So I pull out an x squared. Well, that leaves us with an x plus 3. I pull out a negative 4, leaving us with, hey, look at that. It does factor. So nice. That's awesome. So we got an x squared minus 4, x plus 3. What can I do here? What was that, Nathan? Difference of squares. Thank you. X minus 2, x plus 2. That's everybody out there in the YouTube universe. That's how exciting of a teacher I am. They're yawning as they're saying their answers. Yes. Just combining this here and here. Does that make sense? Okay, so now, again, this is still all equal to 0. So set each one of them equal to 0. So, really, it almost looks like this problem has 3 different answers. But does it really? No, why not? Why not? Because you can't have that many, and you can't have a negative length. You can't have a negative length. So the only possible width, is it width? Yeah. The only possible width to make this true, to fit the parameters, is 2 inches. That would be the width. And we could find the length and the height, 6 and 1. Questions about that? That was fun, right? That's cool.
Great time.
All right, now, so yesterday we had said, let's kind of recap what we did yesterday. That kind of finishes off the notes for day 1. Now we're going to talk about day 2. Yesterday we had said the goal is to find the roots. The goal is to find the zeros. The goal is to find the x-axis, the x-intercepts, right? And then we said, okay, if we have the ability to factor, let's factor, because then we can get it down to its factors, set them equal to 0, and then boom, we have the x-intercepts. But if we cannot factor, then we've got to try something different. Like, think back to quadratics. If we couldn't factor, we had to do either the quadratic formula or completing the square, right? Unfortunately, there's no like polynomial formula. Right? Like, there's no standard formula that you just plug in numbers and it will get you the answer. Unfortunately, that'd be nice. There's no method like completing the square for polynomials. Okay, so we've got to find something different. And what did we do yesterday? Well, that different thing was, let's go to our calculator and graphically find the x-intercepts and factor it down that way. But what if you don't have a calculator? Right? What if we were doing this without a calculator? Well, let's see what would happen. We have this thing called the rational root theorem. The rational root theorem. I'll give you a minute to write that. Again, this is called the rational root theorem. Thank you to whoever don't sub is for subscribing to my channel. Got to know that.
Notifications.
Yeah, I don't know how to turn those on. I get an email every time somebody subscribes to me, and every time somebody comments.
Oh, so I should just count on every one of your videos, just a standard.
blow up.
I'm sorry, but Cooper got first comment. A lot of the other ones.
Oh, first comment. I don't know. After this.
Okay, Cooper, you can get first comment and problem of the week.
The problem of last week.
Problem of last week. I know that one. All right. The rational root theorem says that if any polynomial has integer coefficients, then every rational root of the polynomial can be written in the form p over q. So we're saying that as long as the polynomial has integer coefficients, no decimal coefficients, no fraction coefficients, as long as it has integer coefficients, then if it has rational roots, they can be written in the form p over q, where p is a factor of the constant term and q is a factor of the leading coefficient. P is a factor of the constant term and q is a factor of the coefficients, or the leading coefficient. So what is this telling us? This is telling us that if you don't have a calculator, you can figure out the possible set of rational roots. The possible sets. I'm not saying that when you divide p's and q's that every single one of those is going to be a root. No, that's not what I'm saying. I'm saying that the roots are within that set of numbers. You just have to figure out which ones they are and hope you're a really good guesser. Here's what I mean. Okay, so this can be written in the form p over q. The possible rational roots can be written in the form p over q, where p are factors of the constant term. Ladies and gentlemen, what is the constant term? 2. Okay, well that's really nice. What are the factors of 2? 1 and 2. Now I left some room. Why do I leave room? Because couldn't I also take -1 times -2? Won't that equal back to 2? So a -1 and a -2 are also part of my P list. Okay, my Q list, hey, how about that? What's my Q? Or what's my leading coefficient? So it's the same list as P's and Q's. Okay, that doesn't always happen. That's just coincidence sometimes. Now, the possible rational roots come from P divided by Q. I take my P list and divide it by my Q list. So let's take every element in my P list and divide it by every element in my Q list. Okay, +1 divided by +1. -1 divided by -1. Or sorry, -1 divided by +1. Negative. So I get ±1 as my P over Q list. And then we could take +1 divided by +2. 1/2. I could take -1 divided by +2. -1/2. So I could take +1 divided by +1, -1 divided by +1, +1 divided by +2, -1 divided by +2, and I would get ±1 and ±1/2. Let's start with my 2 now. +2 divided by +1. +2. -2 divided by +1. -2. Okay, now let's go. +2 divided by +2. What is that? 1. It's already on my list. Perfect. Don't rewrite it. And then I would have +2 divided by -2. Get a -2. Or -1, excuse me. So now, this is my P over Q list. What does that mean? That means that every root, every rational root, will come from that list. Every root of this function will come from that list. Now notice that how many roots are there? How many do I see? 6, right? Counting both positives and negatives, I count 6. So I have a possibility of 6 things that I could choose from. So I kind of have a lot to choose from. Believe me, 6 is not a lot. But I have a lot to choose from, and only a couple of them are going to be roots. Only a couple of them. This is without my calculator. If I have my calculator, man, I just go graph this and see where it actually lies. But if I don't have that, well, then I got to go from that list. Let's try one more of those. Okay, so the P is my constant term. P is my constant term, which is -3. Okay, so that means my factors of -3 are ±1 and ±3. Y'all follow me there? Because 3 is a prime number, so it's just 3 and 1. Okay, man, if the leading coefficient is 1, life is good. Life is real good because it's just ±1. And the only factors of 1 are 1. What's wrong?
And
Yeah.
then for Q, do you get it from the first part?
Yep.
So just there. Okay. So that's the constant. That's the leading coefficient.
Yeah. Remember when we were factoring, like, I'd written it on the board, but I've since erased it. You know when we're factoring a hard-type trinomial, what do you do to get the possible factors? Take first times last, right? So there's still this idea of the leading coefficient and the constant term playing a role in our factors. Now what we're doing to figure out, we're kind of like working backwards, so we actually have to divide them, P divided by Q. All right, so P divided by Q is going to be 1 over 1, both positive and negative, 3 over 1. Okay, well, that's even better. I've only got a list of 4 things to choose from now. Okay, that's not too bad. I'm going to skip over that slide. We're just going to go straight to here. Okay, so what if I had said identify all the roots? Identify all the roots. And we were going to put a stipulation on this, and we were going to say NC. What's NC stand for? No. Capital?
Oh, the Haven Airport has a name for that. There's an international airport there.
Charlotte.
Isn't it Raleigh?
I thought it's Raleigh.
It's Raleigh.
I was thinking international.
Oh,
Thank you.
Oh, that's on. That is forever immortalized on YouTube now.
Okay, I'm the Calvin. I'm the dislike.
I'm gonna unsubscribe.
Yeah, you know what?
All right. Okay, so if I okay. If I don't have my calculator, the first thing I would try to do is factor this down. Can I factor this? No. It's a cubic trinomial, right? I can't factor it. I can only factor quadratic trinomials that are of this form. Okay, so I can't factor it. I would then go to my calculator. Oh wait, I don't have my calculator. So I've got to do P's and Q's. Got to mind my P's and Q's. You know what's nice? We just did this problem. We just did this one right here. So I'm just going to go like this. And I'm going to go take a picture.
Oh, it made a noise. That was amazing.
Oh, wait. No.
Oh,
I'm pretty sure just be quicker, right?
oh.
Where'd you go? What? Whoa. Something weird is happening. Okay, yeah, I'm just going to write it. I don't know what's going on. Okay, so I hope I didn't screw up my video. Okay. So P over Q list is going to be, no, I'm still good. I got my microphone thing here. Plus 1 over 2 plus here. Right? I'm just rewriting it from right there. Okay. I have a list of 6 to choose from. Who thinks they're a good guesser? Okay, what do you think? -2. He's going to say -2. Let's check -2. 2, -9, 0, and 2. We've got a 2, a -4, a -13, a +26. Uh-oh, things are getting out of hand. Is this going to work? Nope.
Burn the witch.
So is -2 a root?
No.
No. Let's pick something else. Here's what I'll do. I like to just erase this and choose another thing to put in the box. Okay, somebody else now. Yes.
1 half.
1/2. Let's check 1/2. Okay, so we got 2, a 1, a -8, a -4, a -4, a -2. Bingo. Bingo.
They did it.
Okay, so that means that I could say x equals 1/2, right? Does anybody know the factor that corresponds to that root? I don't want to say x minus 1/2. What would I say instead of x minus 1/2? Anybody? Think about this. What would I do to get the denominator to go away?
Oh my God.
2x minus 1 would be the corresponding factor. Yeah? Because wouldn't that generate a 1/2? Right? Okay, so that means we got 2x minus 1, 2x squared minus 8x minus 4. Okay? Okay, so now I've got 2x squared minus 8x minus 4. GCF? There?
Yeah.
Okay, let's pull it out all the way at the front. X squared minus 4x minus 2. Okay, so now it's a quadratic. Life is good now that I'm at a quadratic because I have a lot more options opening up to me. What are the factors of -2 that add to get to -4? Bummer. Are there any factors of -2 that add to get to -4? Okay, so if I've got a quadratic and I can't factor it, what do? Cry, then you wipe your tears, and then you do what? Apparently a lot.
Oh,
Try
God.
again. Try to factor again. Cry again.
You
Oh.
have to
Try.
No, I don't have to do that.
Do something.
How else do I know how to solve quadratics? The formula?
Formula.
Completing the square? Let's do the quadratic formula. I think you guys like that better. So we've got, quiet folks, x equals 1/2 from this one. Now, are there any zeros associated with my 2 that I pulled out? No. If you just pull out a factor, a numerical factor, no variable with it, it does not get included with one of my roots. So I've just got to factor this, or I've just got to solve this one. X squared minus 4x minus 2 equals 0. Quadratic formula says the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. You might want to remember it.
Oh, that's
So we've got 4 plus or minus the square root of, and then let's put everything inside of. We've got 16 minus 4 times negative 2. That gives me a 24. So 24 inside the radical. So that gives me a 4 plus or minus 2 radical 6, I believe, right? Reducing down to radical 24, because that would be 4 times 6. So it's 2 radical 6 all over 2. And now I can say I divide both parts by 2, right? Like this. So my final answer here would be 2 plus or minus radical 6. So what are my roots? My roots are 1/2 and 2 plus or minus radical 6.
This hurts my brain.
That was fun, folks.
I actually like this a little bit.
Is that a root?
Yeah.
Isn't that just a guys? I know it's a square root, but don't offend the square root. It's still a number. Square roots matter. Is
Square
that
roots
too
are
much?
invalid.
Is that too much?
I do not like this.
That's just 4.4 something, right? That's still a place where it's falling on the x-axis. Now, what kind of root would I get if it didn't cross the x-axis? A non-real root, right? So those you would not see on the graph. You'd say, is that a real root? And you'd say, no, that's not a real root, but it's still a solution to the equation, right? So now we've gotten into this potential for rational roots, irrational roots, non-real roots, all depending on how we solve that quadratic. Okay? Sound good? Okay. Homework's up there on the board. Go ahead and write that down. Have a great day, everybody watching on YouTube. I'll see you all later. Everybody say bye.
Bye.